Hi everyone and welcome back. So in this video we are going to talk about dependency injection at high level and in depth. So for what we are going to do, first we are going to bootstrap the NestJS application with just AI with the type ORM. Okay, we can just do it in the 5 minute, and then because that application is a basic setup, we are going to start building on top of that. We will try to understand in what all different ways dependency injection happens: value providers, use existing, use factory, the dependency injection scope, transient scope, request scope, and a singleton scope. So all those aspects are really in-depth aspect, and we will talk about them one by one. So let's first set up a basic application. I mean, you can just use AI, just do a basic prompt and get your basic application ready with the user entity and user entity with the type ORM, basic things. So this is my basic setup. I mean, we need to start from somewhere. So this is my database config. In this module, user module, app module, we are using type ORM module.for root async. Dynamic initialization of a type ORM module. We are passing the environment variables using config module, user module, and di module. Now what we are going to do is we are going to understand first a dependency injection concept. I already have covered them, but let's talk about them one by one. So dependency injection in the NestJS. So this is how we do it. We just create a injectable class, and now internally either you do provide a user service, or inside providers you just pass user service. It is the same thing. We are providing user service and we are going to give you the instance of user service using use class. I mean, both are same. Okay, NestJS internally register it like this. You are providing user service with the use class of this. If you wanted to inject a particular key like the API key or a runtime configurations, you can do it like this: provide API key and the secret value is this. So how can you inject this inside a constructor? Constructor inject API key, private key. So this key value is a my secret key. Like you can actually do this for the mock service in the testing, config values, environmental constant. So there are three different ways of doing a dependency injection using use class, use existing, use alias, use factory, right? So use class we already discussed, provide, and this is I'm going to provide you the payment service, and the payment service is defined in the Stripe payment service. So injectable name is the payment service, and that is coming from the Stripe payment service. I mean, use class you can use for the dynamic implementation also. Okay, I'm going to give you the payment service, but that's based on the environment variable. Either I can give you a Stripe service or the mock service. So this is the use case of a use class. Use class, use value, use existing. So even if you like iLogger, I can create a multiple injectable instance like iLogger, flogger, mlogger, and I can just use existing logger service instance, right? So in that case, it's just creating an alias provider, iLogger, flogger. These are the two different alias pointing to the same service instance. Use factory, it's like more powerful and give more control to you to inject a dynamic configurations, and this we are doing here already. Type ORM module.for root async. So what we are doing in the database config, here we are using use factory. So we are passing use config service, and inside a config service we are returning all this object, right? So use factory, this means I'm providing database connection, and this is going to happen through the dynamic. So from the config service I will get a DB URL. Maybe that can be for dev, staging, or production, right? So from config service, it's like asynchronous initialization of a database connection. Runtime decision you are going to make, okay, which database connection you wanted to get. Like you are connecting to the three different database, and you are deciding that database based on some instance ID. All those things can happen through the use factory. So it's powerful. Injection token, I mean, you can just do, instead of provide user repo, sometimes it can get conflict, right? So you can do export const user repo. So it will become unique. Sometimes you see a user service and auth service, they are dependent on each other. So how can we avoid the circular dependency? Simple. Inside a provide, you can just use a forward ref, and whenever you are injecting that, you can just use forward ref. So at both the places you need to just use a forward ref so that User service will get auth service will get a user service. You just need to add a forward ref in their individual modules. Now important part is the scope providers. So by default you might remember that NestJS injectable service has a singleton scope, but not every time we need a singleton. Why? Because sometimes we need to extract the context of the request, right? We want new instance of a particular service on each and every request. So in that case you can set a scope request. So there are three scopes: singleton, request and transient. On every request I wanted to log the user context. I wanted to log who is the user session, user ID, correlation ID. In that case you can just have a request context. Now transient scope, where wherever you are injecting a service it will get a new instance automatically, right? So like stateless utility, dynamic builders, they will get new instance on every dependency injection. So how DI container works internally, you already know. NestJS build a dependency graph, resolve provider recursively throughout the whole chain. It caches the singleton instance, and this injectable decorator really matters. Real world advanced example, let's say you are writing a NestJS application and you wanted to connect to different database based on the tenant ID. How can you do that? You can just do that using dynamic initialization, and here we can use factory. I'm giving you tenant DB, but the scope is request. This is important. The scope is request because on every request I'm getting a tenant ID, and based on that only I'm deciding the connection instance. So I cannot just have a singleton. I need to decide the instance of the database based on the request. So the scope is request. Each request will gets its own database connection definition, right? So this is how a DI work. First of all, these are the custom providers like, okay, use existing, use class, use factory, use alias. And then injection scope, circular dependency problem. Yes, it exists. If you have too many forward ref, that means you are doing a poor design. Otherwise, scope provider, transient, singleton and a request, all are really important when you are dealing with the request. So let's see some examples on these. Let's take a look on some examples. Let's say here API key. You can pass a static value or something, and you can inject this API key inside a controller, like inject API key. So this dot API key will be the value which you are passing inside a module, right? It can be a big config object like provide and use value. So in app config you are passing this whole object, right? Then we have a payment service. Inside payment service, you are using provide and use class. What does it mean? That based on the environment, we are deciding, okay, we are going to use either, if it is production, then Stripe payment service, otherwise mock payment service. Then similarly, we are using use existing. I mean, I have a logger service, but I can create a dedicated multiple instance, but both resolve to the same logger service. Here logger service, it will create a logger service instance, and then there is I'm also providing iLogger. iLogger will also give the same logger service instance. Then another thing is the database connection that I was talking about. At runtime, if you want to decide the database instance, then you can do it like this: provide use factory. So I mean, it's a singleton, right? But at the runtime, we are deciding the connection string. It's called a dynamic initialization or asynchronous initialization with injected dependencies, like type ORM module.4root async. There we are injecting a config service, and based on that we are creating the instance of so the same thing we are doing here, database config app module, right? Type ORM module.4root async, and here inside a config, based on the runtime, we are actually passing this URL, database URL for that. So these are the three different possible ways of a dependency injection. So another use case I was talking about, the cyclic dependencies, right? User service and auth service, they depends on each other. So what we can do to resolve that, inside a auth service, you can do a forward reference. Inside a user service, you can do the forward reference. And this is how you can resolve the cyclic dependencies of a user service inside auth service inside a user service. Both are part of the one common module. Things will be different when these are the two services which are added in two different modules. Then at module level also you need to add a forward reference. But here both these services are inside the same module. So we are just doing a forward ref in the constructor injection of a user service and auth service. This is how you will resolve the two different dependencies. So I created a request context service. What is the use of it? It is just use of it is just logging the user context, logging the session, logging the header, logging the tenant, logging the timestamp and all. So what I want to do is on each and every request, we get a dedicated instance of the request context. So at the injectable, I will just pass scope is request. That's it, the plain and simple, right? For the database, tenant database, it is also request because at the runtime at the database, at runtime, I have a tenant map. If the tenant which is coming inside a request is X tenant ID, it can be header. I can access the request object. You can inject a request, and based on that, I am creating the tenant map and initializing the database connection like this. Okay. So similarly, the transient logger, it means wherever you inject this transient logger, that service will get a new instance of it. Okay, so we can have a separate instance ID. Similarly, the Stripe payment service or mock payment service. If you are on the production, then we will use Stripe payment service. If you are on the development, then we will use the mock payment service that we have already added here. That payment service will be providing the instance of either Stripe payment service and mock payment service based on the runtime, based on the environment variable. So similarly, these are the use values. This is the use class. This is use existing. This is use factory, and these are the some of the example of the the scope of the instance of an injectable class, either a request, transient, or a singleton. Like cache service should be a singleton. Let me just check. Yes, this is a singleton, right? So in memory cache implementation, the single instance is available, but all the other things like request context, scope is a request. Stripe payment, global tenant database, scope is request. Transient, scope is transient. So these are like some common aspects. If you are end-to-end done with these things, that means you know the core of the dependency injection framework of the NestJS.